Hello, my name is Mason Dana, and here I will show my R code for the salary problem on our midterm. So first things first, as always, I set my working directory to where the data can be found. So in order to do this, I went to Session, Set Working Directory, and then to Source File Location. So this is really helpful if you have downloaded this from somewhere. So I got this data from Moodle, from our class resources. And so then I saved it into a folder on my computer where I know the location. So this was really helpful. Although sometimes this doesn't always work. So if it doesn't work for you, you can choose the directory manually. And it's better to choose the file that the folder where the actual file is located and not the file itself. And then I set this so that I can have an actual table readout of the salary data. So if you look in my environment, there's a table here if you click on Sal. So here's all the information. But look at this, like, it's really difficult to interpret. I don't really know what's going on here. So instead, I can use my R code to understand what's going on. So the first question was, how many female and male faculty are in the arts, professor, and other? Arts, prof, and other, sorry. So in order to do this, I first wrote this code down here that says table and then of salary, so of the data frame salary, and for it to be the genders. Now, if you run this, you just get F for female, M for male, and then it tells you just the raw data. So it just tells you 3,927 and then 15,866 for men. But that's not really telling me exactly like who's in arts, prof, or other. So in order to specify further, I used, again, the table function. And I said table sal, so again, that's sal data frame, and field. So here it's going to tell me the field that they're in, so either arts, prof, or other. And here I'm specifying even further that I want this to be in a table with the gender column. So if I run this together, you get this down here. So here, 1 is female and 2 is male. So if you look at this, you can see the exact numbers of how many women are in arts and how many men are in arts, how many of them are in other, and how many of them are professors. So the second question is calculate the mean salary for faculty in the field of arts and prof. So in order to do this, I took a two-step approach. So first I defined two things. So one, I have AS, which stands for arts salary, and then I have PS, which stands for prof salary, so professor salary. So here I want the AS to be the salary information in the SAL data frame, but I want to specify it by field, so the field column in the SAL data frame, and I want the field to be arts. So I use this double equal sign to specify that the field that I'm looking for is just arts, and I put that in quotations. I do the exact same thing for PS. So the SAL data frame, I want to know the salaries, but specifically, I want to know the fields in the salaries, and even more specifically, I only want to know the professor salaries. And so now that I've defined that, so let me run that so that it goes into my environment if it's not already there. And then I want to know the mean of these two. So I just use the mean function. So mean function AS and mean function PS here. So I'm going to run that. And here it shows us that the mean for an arts professor is 3,845.621. And the mean for professor is 5,470.351. So the next question is asking if there's a significance between these two salaries. And in order to do this, they're asking that I calculate the p-value for this. So in order to calculate the p-value, you can run a t-test. So I just use the t-test function, and I do a t-test on AS and PS. So on the art salary and the professor salary. And here the t-test gives you a lot of information, but most importantly, it gives you the p-value. Now, if your p-value is above 1, that means that there is significance. So here p-value is 2.2 e to the negative 16. So there is a significant difference, a statistically significant difference between these two. Now, if you look up, the difference is $2,000 almost. So it makes sense that there would be a statistical difference. So next it's asking me to explain what HO and HI are. So I just typed it out and I will read it to you. So HO and H1 are a part of a statistical theory where HO represents null, or there being no association between the values and it happening alone in nature. And H1 represents the alternative hypothesis that states that there is some correlation. So essentially, this is related to the p-value. So HO means that, it's just a coincidence. It just happened naturally. And H1 is saying, no, there are things that are working to cause this to happen. So our last question is, how many female faculty started their jobs in 1885? So the first function I wrote was just a simple table that I did up here, not the same one, but the same function. So table, I want the gender column and the salary data frame, but more specifically, I want to know the start years. So if I run this function, it gives me all of the start years ever and how many women and men started in those start years. So I can't just look and say, okay, they want me to see how many people started in 85. If I go to 85 and I go to the female column, I see that it's 208. But I can also make this more specific. So I can run table, and I want the gender, column, and salary, and more specifically, I want to know the start year and the salary. But I want the start year to equal 85. And again, I'm using this double equal sign. So if I run this function, it just gives me 1985. And here we see the total number of female faculty and male faculty. And for 208 of them, it is true that they started in 1985. So these are giving me the same information. Well, I hope that was informative and fun to watch. And I also hope you have a great day.